Hi, welcome to my video on simplifying exponential expressions. We're going to simplify each, but let's recall that b to the m times b to the n equals b to the m plus n. An example, 2 cubed times 2 squared is 2 to the 3 plus 2, which is 2 to the 5. And when we divide b to the m divided by b to the n, we subtract the exponent m minus n. X 10 divided by x to the 4 is x to the 10 minus 4, which is x to the 6th. And also the power rule, b to the m power to the raised to the n power, you multiply m times n. An example is x cubed to the 4th power is x to the 3 times 4, which is x to the 12th. So we're going to use those rules when we simplify with fractional exponents. So here we go. X to the half times, so the bases are the same, so we write down the base, and when we multiply, we add the exponents. So a half plus a half is 1, so that's x. Again, we have the same bases. We write down the base, we're multiplying, so we add 3 over 4, add on 5 over 4, common denominator is 4, 3 plus 5 is 8, and that's y squared. And again, we're multiplying with like bases. The like base is x. So when we multiply, we add the exponents. And common denominator is 2. Negative 5 plus 7 is 2. And 2 over 2 is 1, so that's just an x. And again, we're dividing, so we have like bases. We have to have the same bases, which is g. And when we divide, we subtract the exponents. Base is g, common denominator is 5. 19 subtract 4 is 15, so that's g cubed. E, we're multiplying, dividing, same basis. Base is d. Multiply 17 over 3. When we multiply, we add 11 over 3. When we divide, we subtract negative 2/3. And a double negative makes a positive, so d, common denominator for all three of these is 3. 17 plus 11 is 28, plus 2 is 30, and 30 over 3 is 10, d to the 10, simplified. Now we have a monomial times this binomial, so we multiply these two. We get x to the half times x to the 5 over 2. Add on x to the half times x to the 3 over 2. Because we're multiplying with the same bases, we add as a half plus 5 over 2. And the same here, because we're multiplying like bases, exponentials, we keep the base, and we add a half plus 3 over 2. So 1/2 plus 5 over 2 gives us 6 over 2. And 1/2 plus 3 over 2 gives us 4 over 2. So that's x cubed plus x squared. We cannot add these because they're not like terms. And we have the power here. So when power of a power, we multiplying fractions, we cancel. 3's cancel, 1, 1. The 2 cancels into 10, 5. So we get x to the 5. And h, we're same base as f. And because we're dividing, we subtract the exponents. So it's 2/3 subtract 1/6. And a common denominator for 3 and 6 is 6. So 3 into 6 goes 2. 2 times 2 is 4. subtract 1/6. That's f to the 3/6. So that equals f to the half. And we have done some examples. Now, if you wish, let's turn to the next page. And we have a practice page, which means that you can work out these yourself before I do them to see if you get them right. Here we go. Pause the video and write these down and work them out. So here I'm going to work them out now. So same basis, we're multiplying, write down the base. When we multiply, we add the exponents. So we add, so 1 plus 8 is 9 over 3, so that's x cubed. And again, we have the same basis, we're multiplying, so we add 17 over 13, add on 9 over 13, so h equals, common denominator is 13, 17 plus 9 is 26, 26 over 13 is a 2, so it's h squared. Number 3, we have the same basis, we're dividing, so we keep the base and we subtract the exponents. And the common denominator is 4, 11 subtract 3 is 8, 8 over 2 is 4, so y squared simplifies to. And number 4, we're dividing, we have the same basis of t, so when we divide, we subtract, so it's 5 over 6, subtract negative 11 over 6. And a double negative is a positive, so t, common denominator is 6, negative 5 plus 11 is 6, 6 over 6 is 1, so we just get t. And number 5, we have the same basis of f, so we write down f, and because we're dividing, we subtract 2/5, and because we're multiplying, we add negative 4 over 5. So common denominator is 5 for all these fractions, and 16 subtract 2 is 14, and 14 subtract 4 is 10, and so that's f squared. And we have a monomial times a binomial, so we multiply these two, so it's p to the 3/4 times p to the 17 over 4, and we multiply, subtract p to the 3/4 times p to the 13 over 4. So notice p to the 3/4 is multiplied by each of these. There it is. And because we're multiplying, same basis as p, we add the exponents. So it's 3/4 plus 17 over 4. Subtract, same base. Because we're multiplying, we add 3/4, add on 13 over 4. And we add, common denominator is 4. 3 plus 17 is 20. Common denominator is 4. And we get 3 plus 13 is 16. So 20 over 4 is p to the 5. And 16 over 4 is 4. So p to the 5, subtract p to the 4. And we can't subtract these because they're not like terms. Number 7, we have to obey PEMDAS, P-E-M-D-A-S. That's a D. No exponents, no brackets, no parentheses, no brackets. We have to do multiplication, division as we wish, to left to right. 6 times 1 is 6. Same basis as x. So because we're multiplying, we add 14 over 3, add on 1 over 3. And the same basis as x. And because we're dividing, we subtract 19 over 3, subtract 4 over 3. Simplify, 6x to the 15 over 3. That's x to the, subtract 19 is 15 over 3. So that's 15 over 3 is 5. 15 over 3 is a 5. And notice that these are like terms, same exponentials. So 6 plus 1 is 7x to the 5. And again, we have to do number 8, an example, a little bit different. We have a power of a power, so we have to obey PEMDAS. which is right here. We have to do our powers first, and so we cancel the 4's. 3 and the 9 goes 3, so that becomes y cubed. And the 10's cancel. 7 and 14 goes 2, so it becomes y squared. And we can't subtract these because they're not like terms. And that brings us to the end of the simplifying exponential expressions with rational exponents. If you like my video, click the like button, the subscribe button, the notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.